All right, welcome back, everyone. So today we are going to be going through an equations review of everything that we have covered thus far back in chapter 1 because it's still prevalent in solving equations because we're soon going to have to be solving equations. So we want to make sure that we are up and fresh about how to solve these equations. We are going to be going through 5 different examples of how to solve equations, how to solve one step, two step, multi-step and equation with variables on both sides. And in this video, we're going to be working on problems directly from your worksheet. So without further ado, here we go. First problem we're going to be working on is problem number 1. Look at that. So we have 15 is equal to n plus 8. We want to isolate that variable. So I'm just going to highlight the variable real quick just so that we are aware. So we want to get the variable n all by itself, and it's currently n plus 8. So we don't want that plus 8 there anymore. So we're going to have to use the inverse operation of addition, which is subtraction. Remember what we do to one side, we do to the other. This now goes to 0. So now we do 15 minus 8, which is equal to 7, and we drop down that n. Now, we don't need to do anything else because it's just n, right? It's not 5n, it's not negative 6n, it's just n. The coefficient is 1, which is perfect. So n is going to be equal to 7. And that's how to solve a one-step equation by using subtraction. We now also can talk about multiplication and division. So in problem number 5, we have p over 20 is equal to negative 5. Now, I know I said over 20, but really we're saying p divided by 20 is equal to negative 5. So I'm just going to cover this up real quick just to make it a bit easier for us to see. So we have p divided by 20 is equal to negative 5. Well, we're going to use the inverse operation. The inverse operation of division, you guessed it, or you know it, you can guess it, you know it, is a multiplication. So we're going to multiply both sides, by 20. What we do to one side, we do to the other. So we drop down our variable. So p is going to be equal to negative 5 times 20, whatever that product is. Well, I know a negative times a positive is a negative, and 5 times 20 is 100. So I get negative 100. I get a negative Benjamin. And we were using those inverse operations again, and this is a one-step equation, which eventually all equations come down to a one-step equation. So if we can do a one step, then we are going to be scaling it. So let's move on to the next problem, which is problem number 9. And probably asking yourself, Mr. Q, why did you write it twice? Or why did you put it twice? Well, because there's 2 ways to solve this type of problem. And you might have in your head one way that works with you, and that's totally great. But we're going to be going through 2 different ways because there are 2 different ways. Now, whichever way works best for you, use it. I'm never going to tell you, hey, only do it this way, because that's not how life works. You have your own way of thinking and your own way of problem solving. So long as we're solving the problem, then we're going to be okay. You might have a certain method that works for you, use it. Okay, someone else might have a different method that works for them, use it. Okay, it's whatever you feel most comfortable doing. And I'm going to go through 2 different methods in order to solve this problem. So I notice I have 3 times a quantity, negative 4 plus r, and that's equal to 18. I look inside my set of parentheses and I do not have like terms, so I cannot combine them. Negative 4 and r are not like terms. So we're going to use the distributive property here. We're going to distribute 3 inside our set of parentheses. So 3 times negative 4 is negative 12. 3 times r is going to be 3r. That's going to be equal to 18. Now, I want to isolate that positive 3r. In order for me to do that, that would mean negative 12 has to go to the other side. So in order for us to do that, we want that to be 0. Well, how do we get it to be 0? Well, we add 12. Negative 12 plus 12 is 0. Therefore, we drop down that 3r. 18 plus 12 is equal to 30. Should probably have an equal sign there. Much better. So now we have 3 times r, which is a one-step equation. So in order for us to solve this, we have to divide both sides by 3. We get r is equal to 10. Perfect. And now that's one way to do it. Now I'm going to show you another way to solve this that you might have initially wanted to do. So we have 3 times the quantity, negative 4 plus r, is equal to 18. So it's 3 times the quantity is equal to 18. And the distributive property uses multiplication. So really what we're doing here is 3 times that value of whatever negative 4 plus r is, I'm going to multiply by 3. Well, since I'm using multiplication and there's no other terms around, we can divide both sides by 3. When we do that, we're left with what's inside our parenthesis, negative 4 plus r. That's now going to be equal to 6. And now, again, we have a one-step equation. We have negative 4 plus r is equal to 6. I want that negative 4 to turn to 0 and move it to the other side. So I have to add 4. So I get that r is equal to, you guessed it, positive 10. Ooh, and look at that. We get the same overall value. We just did it a different way, right? And that's totally fine. So long as we end up with the same result, we are going to be A-OK. All right, we got 2 more to do. This is problem number 13 on your worksheet. You have negative 90 is equal to 2 plus 4 times a quantity 1 plus 4k. Now, this might look a little bit intimidating, but we've done this before. You've rocked this before, so you're going to be completely okay. You might just have to dust off the cobwebs, but you are going to be skilling this. So we always want to work with our order of operations. PEMDAS, please excuse my dear Aunt Sally. So we look inside our parentheses and see, can we simplify? Well, we have 1 plus 4k. Those are not like terms, so we cannot simplify. We also don't have any exponents. So now we move on to multiplication or division, whichever one comes first. So we're going to be using the distributive property here by sending the 4 into the set of parentheses. We're going to drop everything else down. So now we have 4 times 1 is positive 4. 4 times 4k is positive 16k. We always want to simplify before we start to move anything over. So we ask ourselves, is there something that I can simplify? Are there any like terms maybe? Yeah. 2 plus 4. Those are like terms, so we can simplify it. We're going to drop down negative 90. We know 2 plus 4 is equal to 6. And we drop down our 16k. So now we want to isolate our variable. We have negative 16k. We want that to be all by itself, all by its lonesome. So that means we have to move that positive 6 to the other side. And to do that, we're going to subtract 6. This goes to 0. Negative 90 minus 6 is negative 96. Now we drop down that 16k. And it's 16 times k, so we want to divide both sides by 16. When we do that, we get negative 6 is going to be equal to k. And again, this all starts by simplifying both sides before we start to move anything. Once we're fully simplified, then we can start to move. If we do it too early, then we're going to potentially confuse ourselves. So we just want to simplify first. We want to simplify. Perfect. All right, we got one more problem that we're going to be doing together. Negative 6x plus 24 is equal to negative 2 times 5x minus 8. One of the first things that I notice when I look at this problem is I have a term with a variable on both sides of my equal sign. I have a negative 6x on the left-hand side. I right now have a positive 5x on the right-hand side, which means eventually I'm going to have to move my variables to one side and my constants to the other. But we can't do that just yet because we have all these other terms going on. So we want to look at each side and see if we can simplify. Can we simplify? Well, can we simplify negative 6x plus 24? Are those like terms? Nah, we can't. But can we simplify negative 2 times the quantity 5x minus 8? Darn tootin' we can. We can use the distributive property to send that negative 2 inside the set of parentheses. We're going to drop down everything else that we aren't working with. Negative 2 times positive 5x is going to be negative 10x. Negative 2 times negative 8 is positive 16. Make sure we are aware of our signs. They're very, very important. So now again, we ask ourselves, can we simplify? Well, can we combine to negative 10x plus 16? No, we can't. So I'm going to hit you with the Q-tip that we gave you a while back. You want to move the smaller coefficient. And why we're going to be doing that is because when we move the term that has a smaller coefficient or the least valued coefficient, we're going to end up with a positive coefficient for our variable, which eliminates any possible issue of dividing by a negative. Right? Sometimes we forget that when we divide by negative, it's dependent on what we're dividing into. So we just want to make sure that we have a positive coefficient and we are staying positive, right? Hashtag 2021, stay positive. So we want to move the smaller coefficient. So the coefficients that we're going to be comparing are negative 6 and negative 10. Which number is technically smaller? Yeah, negative 10. Because I don't know about you, but I wouldn't want to owe $10. I mean, I don't really want to owe $6, but I'd rather owe 6 compared to owing 10. So we're going to move the smaller coefficient. In order to do that, we have to add 10x to both sides. Negative 6x plus 10x is positive 4x. We drop down everything else. Plus 24 is equal to 16. We have our variables on the left-hand side, which means we now have to get our constants, or our non-variables, to the right-hand side. That means positive 24 has to move over to the other side. In order to do that, we have to subtract 24 by using those inverse operations. Now we have 4x is equal to negative 8. The last step is to isolate that x. We want to get our x all by themselves. We have to divide both sides by 4. And we get that x is equal to negative 2. Awesome job today, folks. We just went through examples on how to solve one-step equations, two-step equations, multi-step equations, and equations that have variables on both sides. Keep up the good work, and I will talk to you soon.